ఎవరైతే జూమ్ లో జాయిన్ అవుతున్నారో వాళ్ళ ఇన్స్టిట్యూషన్ పేరుతోటి జాయిన్ అవ్వండి. ఝాన్సీ గారు, నందు, పరశురామ్, మనీషా, శ్రీనివాస్, తర్వాత శంకర్. మీ ఇన్స్టిట్యూషన్ పేరుతో జాయిన్ కాకపోతే మీ ఏ ఇన్స్టిట్యూషన్ వాళ్ళు అనేది మాకు తెలియదు. అటెండెన్స్ లో మీరు జాయిన్ కాలేదనే ఇస్తాము రిపోర్టు. దయచేసి ఏ ఇన్స్టిట్యూషన్ లో జాయిన్ అయినా కానీ వాళ్ళ నేమ్ పక్కన ఇన్స్టిట్యూషన్ పేరుతోటి రీనేమ్ చేసుకోండి. మళ్ళీ చెప్తున్నాను, నేను ఇన్స్టిట్యూషన్ పేరుతో రీనేమ్ చేసుకోండి. శంకర్, శ్రీనివాస్, మనీషా, పరశురామ్, నందు, ఝాన్సీ గారు రీనేమ్ చేసుకోండి దయచేసి. తర్వాత విద్యార్థులు ఎవరైతే వింటున్నారో క్లాసు, ఎటువంటి అమ్మ ఝాన్సీ గారు రీనేమ్ చేసుకోండి. ఇన్స్టిట్యూషన్ పేరుతోటి రీనేమ్ చేసుకోండి. మీరు ఏ ఇన్స్టిట్యూషన్ అని ఎట్లా తెలుస్తుంది? మీరు ఇన్స్టిట్యూషన్ పేరుతోటి మీ డివైస్ ని రీనేమ్ చేసుకోలేకపోతే మాకు ఏ ఇన్స్టిట్యూషన్ ఎట్లా తెలుస్తుంది? దయచేసి ఇన్స్టిట్యూషన్ పేరుతోటి రీనేమ్ చేసుకోండి. తర్వాత విద్యార్థులు ఎవరైతే క్లాస్ వింటున్నారో మీకు ఎటువంటి డౌట్లు ఉన్నా కానీ దయచేసి అన్ని నోట్ చేసుకొని, సార్ లాస్ట్ కి మీకు ఒక 15 to 20 minutes టైం దొరుకుతుంది. ఆ టైం అప్పుడు దయచేసి మీ క్వశ్చన్స్ అన్ని కూడా సార్ని అడగండి, సార్ క్లారిఫై చేస్తాడు. థ్యాంక్ యూ.
Good afternoon, friends. Today I will going to explain the concept of elastic potential energy in a string or in a rod, stitched rod or spring. Okay. What is an elastic potential energy? See, suppose when we have, suppose consider a rod, this and a rod. Okay. One end is fixed like this. One end is fixed at rigid support, and other end is pulling with a certain amount of force like this, with certain amount of force F. Then what happening is that the rod would be expands a small elongation like this. The rod would be expands a small elongation, that way you will take delta x. So at this point what happening is that the restoring force will act opposite direction of our applied external force. Okay. Let's take it has some constant k. What is that force constant k? The rod has a force constant k. If the force is applied more, what happening is the elongation is also more. If the force applied is small, the elongation is also small. That means the applied force is directly proportional to elongation of this rod. That means let's say it has to be expanded elongation of a small elongation. What was taken here? Delta x, x take here x. You can take x. These are x takes small elongation x. Initial length of the rod would be nothing but L take. Okay. For this purpose, the amount of work done for this purpose, how much amount of work we have done there? We have done the work would be is equal to dw. So dw is equal. What is that? Dw would be is equal to f into dx minus f into dx. So what is the value of f? F means what is f? F is equal to, f is direct proportional to x, okay, which is opposite direction. That is equal to, f is equal to minus k into x, where k is called as a force constant. This value put in the above equation. Then what you will get, see here, dw would be is equal to minus integration of f means minus k into x into dx. Here the x value would be is equal to 0. Here x is equal to L. X is equal to L. The amount of work done to elongate the wire from x is equal to 0 to x is equal to L is given by, what is that? dw is equal to minus of minus plus. You will get it plus only here there. Plus that is equal to integration of x take common here. X is a common. X is equal to 0 to L into x into dx. This is what I am writing. इसके लिए integration कर. That is dw is equal to k x square upon 2 between the limits of 0 to L. So the work done is stored in the form of a potential energy. That is U is equal to k into instead of the express you can substitute L. L square upon 2 or L square upon or 0 to x L square upon 2 हो जाता है. This is, or you can put like that only. What you will get there? What you will get here from the 0 to x only take here, not 0 to L here. 0 to L, that is u is equal to k L square upon 2, or you can put instead of the L plus x only you can put. For delta x के लिए small amount of work has to be done there. The work done is equal to k into what is the k? K into integration of x dx into 0 to x level. Okay, that is the w is given by w is equal to k into x square upon 2. This work done stored in the form of a potential energy, that is called u is equal to kx square upon 2. This is what I am writing. U is equal to kx into x upon 2. So kx is nothing but what is the value of kx? Kx is nothing but f. Therefore, the electrostatic potential is given by f into x upon 2. So this much amount of electrostatic potential energy has to be stored in a rod or spring. Okay. So energy density. What is energy density? The energy per unit volume is called as an energy density. The elastic potential energy density is generally divided by E is called U upon V. That means energy per unit volume is called as energy density. This is the energy density. Energy density. The energy density would be is equal to E is equal to U upon V. That is E is equal to what is the U? What is the value of U? U value was already known. That is equal to U means what is that? U means f dot x upon V value what I am writing? A into delta x I am writing. Delta x, that is called area into volume. That is called f upon A into x into delta x of as I am writing here. See. So f dot x, so u value is by 2 here, right? Because of u is equal to kx or f dot x upon 2. So that is this is what I am writing. See here, E is equal to energy density is equal to half into this value stress into strain. This is called as a stress into strain. This is called as energy density. Therefore, the energy density is given by E is equal to half into stress, half into stress into strain. Half into stress into strain is called as a energy density. But already know what is a Young's modulus is given by Y is equal to Young's modulus is given by stress upon strain. Stress upon strain. Stress upon strain. So from the stress is equal to what is the stress? Stress is equal to Y into strain. Y into strain हो जाता है. That is the energy density would be is equal to half into Y into this value substitute here. What you will get? Strain square. Strain square. This is a energy density. The scale strain square you should write like this. Suppose consider rod है. इसमें rod लो. एक rod लो, इसका rod है rod. Initial length has a L. When we have applied some amount of the force, what happening is that it has expanded a small length delta L. Therefore, strain would be is called what is the strain? Delta L upon L is called as the strain. This value put. Then you will get the strain energy in the form of changing length by original length. That is equal to energy density. E is equal to half into energy density. E is equal to what is that? Half into Y into delta L upon L of whole square. This is a strain energy or energy density. Energy density. The elastic potential energy density is given by like this. E is equal to half into Y into delta L upon L of whole square. Okay, is it clear? Is it clear, all of you? Next, see, this is what I'm writing. See here, the problem is based on this concept. Problem, JE problem. So we JE problem है बेटा. Okay. Suppose consider a while before. Suppose if the y was given like this, y is equal to 2 into 10 to the power of 11 was given, Newton per meter square. Okay. Chain length by original length was given like this. What is that? That is the strain was given. Strain is equal to, what is the strain? 10 to the power of -4 was given. Then find the energy density of the rod. In a rod ऐसा दी है. Rod में rod का young smallest was given like this, and इसमें strain produce के with a 10 to the power of -4. Then find the energy density is there. Okay. What is the energy density? The energy density would be E is equal to half into 2 into 10 to the power of 11 into, what is that value? 10 to the power of -4 of whole square. Strain, this is strain. Strain was given 10 to the power of -4 of whole square. 2 gets cancelled out. E is equal to 10 to the power of 11 into 10 to the power of -8. Therefore, E value is equal to 10 to the power of 3, 10 to the power of 3 joules. So the strain energy, sorry, the elastic energy density in a rod would be is equal to 10 to the power of 3 joules. Is it clear? Is it clear or not? Okay. No. Next thing. The next concept is a Poisson ratio. Poisson's ratio. Poisson's ratio. What is a Poisson ratio? Suppose consider a rod. This is a rod. The rod of one end is fixed here like this. Okay. The rod of one end is fixed here like this. And it has some radius R. The rod has some radius R. Some radius R. The rod has some radius R like this here, which is fixed. And the rod has a radius R and length here, which is fixed at one end. Where the second end at this point, when we have applied some amount of the force like this, F newtons, what happening is that the rod has to be elongated like this through a small length delta L. Okay. When it is elongated, automatically what happening is there, the width of the rod would be decreased like this. A small length of the width of the rod, small diameter of the width of the rod has to be decreased like this. The width of the rod has to be decreased like this. How much radius it has decreased? Delta R. This is called as a transfer constructions. So what is the transfer constructions? The change in radius to original radius of the rod is called as a transfer strain. Therefore, the transfer strain in this, what is the transfer strain? Transfer strain is equal to minus delta R upon R. Here, the length also changes here from L to L plus delta L. The rod has to be elongated through a small length delta L. The total length of the rod would be equal to L plus delta L. Therefore, it has some longitudinal strain also. Longitudinal. What is the longitudinal? Longitudinal strain. Longitudinal strain. Longitudinal strain would be equal to delta L upon L. So the ratio of transverse strain to longitudinal strain is called as what it is called? Longitudinal strain to transverse strain. This is called as a Poisson ratio. It is denoted by sigma. Sigma is equal to transverse strain to longitudinal strain is called as a Poisson ratio sigma. So this is what I'm writing. Sigma is equal to minus delta R upon R upon delta L upon F. Therefore, the transverse strain delta R upon R would be is equal to minus sigma into delta L upon L is called as a, this is a transverse strain. Longitudinal strain is a delta L upon L. Okay. This is a Poisson ratio. So what are the values? So theoretical values are, its theoretical values. Theoretical values are minus 1 to 0.5 and practical values are practical values are 0.2 to 0.4. These are theoretical values. Those are the practical values. That is called as Poisson ratio. It is also important for JEE mains purpose. For JEE mains purpose, this concept also important. So what is a Poisson ratio? Poisson ratio means the ratio of transverse strain to longitudinal strain is called as a Poisson ratio. It is denoted by sigma. Sigma is equal to minus delta R upon R by delta L upon L. This is a what is that Poisson ratio? From this transverse strain, we can written as minus sigma into delta L upon L. So its theoretical values are minus 1 to 0.5 and practical values are 0.2 to 0.4 are the practical values. Suppose the applications of the Poisson ratio, see here. What are the applications of Poisson ratio? Yes. Applications. Application of the Poisson ratio, see here. Suppose consider a rod. This is a rod. It has a length L. Suppose consider rod of length L. Okay. Its area of the cross section is A. Area of the cross section is A. It has a volume is V is equal to, what is the volume? L into area. This is L. L into area, V is equal to pi r square L. Pi r square into L is a volume. Okay. When we had applied some amount of the force on it, then find the change in volume of the rod. How much amount of the volume has to be changes in this? That is, we should have to calculate now. The change in volume of the rod is given by V is equal to pi r square L, A beta, pi r square L. From this, V is direct proportional to R square into L is already you know. So the change in volume can be written as delta V upon V is equal to 2 into delta R upon R plus delta L upon L. Okay. But the Poisson ratio can be defined as what is that? Sigma is equal to minus delta R upon R upon delta L upon L है, ठीक है. इसमें डेल्टा आर अपन क्या मिल जाता है बोलो? डेल्टा आर अपॉन आर इज इक्वल टू माइनस सिग्मा इंटू डेल्टा एल अपॉन एल है बेटा. वो इसमें लगाओ, क्या मिल जाता है इससे बोलो? क्या मिल जाता है? सिग्मा इज इक्वल टू क्या मिल जाता है बोलो? माइनस 2 सिग्मा इंटू डेल्टा एल अपॉन एल प्लस अगेन डेल्टा एल अपॉन एल. Therefore सिग्मा इज इक्वल टू इसमें डेल्टा एल upon L common करो 1 minus 2 sigma. This is a what is that Poisson ratio of that rod. Sorry, change in volume. We have to calculate change in volume. We have to calculate change in volume. Delta V upon V. delta V upon V, and this is not a sigma. What is the delta V upon V? Delta V upon V is equal to the change in volume is given by delta V upon V is equal to minus 2 sigma into delta L upon L plus again delta L upon L हो जाता है. That is delta V upon V is equal to delta L upon L common करो 1 minus 2 sigma. This is a fractional change in volume. The fractional change in volume of the rod is given by this much है बेटा. The percentage change in volume क्या हो जाता है? Delta V upon V into 100 is equal to delta L upon L into 100 into 1 minus 2 sigma. This is a percentage change in volume. This is a fractional change in volume of that rod. Okay, is it clear? Is it clear or not? Respond. Okay. Next to see. Based on the concept of Poisson ratio and elastic potential energy relation के क्या हो जाता है देखो इधर. Suppose consider a wire of length 2 meters है बेटा. एक वायर दिया है ऐसा. तो वायर दिया है ऐसा. Wire was given like this. A wire of length. A wire was given like this. A wire. इसका n smallest y is equal to 2 into 10 to the power of 11 Newton for meter square was given. Y is equal to 2 into 10 to the power of 11 Newton for meter square was given. Okay, and transverse strain was given. What is the transverse strain in this? The transverse strain, that means when a force of F newtons is applied on this, the wire is undergoes in transverse strain. The wire is undergoes in transverse strain. Okay, the wire has to be undergoes in transverse strain. That would be equal to delta R is equal to 10 to the power of minus 3 was given. Delta R upon R is equal to 10 to the power of minus 3 was given. Okay, and it has the Poisson ratio sigma is equal to 0.2. Then calculate the energy density, elastic potential energy density of the rod. This is a JEE 2025 का question है बेटा. JEE 2025. Find the energy density of the rod I showed in the figure. Find the elastic energy density. Elastic energy density. Find the elastic energy density of the rod. As shown in figure. Find the elastic. What is that? Find the elastic energy density of the rod. I showed in the figure. This is a 2025 question है बेटा. कैसा निकालना पड़ता है बोलो? Y दिए, sigma दिए, and transverse strain दिए. Transverse strain is the 10 to the power of minus 3 दिए. कैसा निकाला पड़ता है इसमें? So the elastic energy density in a rod is given by E is equal to half into Y into delta L upon L of whole square is already known. Okay, this is elastic energy density formula. And all values, but what was given? Young's smallest was given, sigma was given, but strain, longitudinal strain was not given here. In this problem, we should have to calculate the longitudinal strain, but transverse strain was given and Poisson ratio. So from that given values, we should have to calculate what is that longitudinal strain. Sigma is equal to already, the Poisson ratio sigma is equal to, what is that, minus delta R upon R by delta L upon L. इससे क्या मिल जाता है बोलो? Delta L upon L is equal to minus delta R upon R is divided by sigma is already Okay. So this value was given. What is the value? the longitudinal strain delta L upon L is equal to, the transverse strain was given 10 to the power of minus 3. Okay. 10 to the power of minus 3. Minus 10 to the power of minus 3 upon what is that? 0.2. 0.2. This is what I am writing here. 10 by 2 into 10 to the power of minus 3 of minus, I am writing here 2 ones are 2 5s are, that is delta L upon L would be is equal to minus 5 into 10 to the power of minus 3, where negative sign is represented by decrease, where negative sign is represented by decrease transfer strain. So this value substitute in this. So what you will get here, see, E is equal to half into Y value was given 2 into 10 to the power of 11 into delta L upon L is equal to minus 5 into 10 to the power of minus 3 of whole square. Okay, 2 gets cancelled out. Therefore, E is equal to 10 to the power of 11 into 25 into 10 to the power of minus 6. So therefore, the energy density would be is equal to 25 into 10 to the power of 5 joules. This much energy density has to be present in this rod. Okay, is it clear? So what is here the logic? What is the logic? The logic, the logical trick is that we should have to calculate the longitudinal strain from the Poisson ratio and transfer strain. That is the logic point in this problem. Okay, is it clear? No doubt. Next concept, see, bulk modulus. Next one is the bulk. Bulk modulus. Bulk modulus K. Some authors are represented by K, or some authors are represented by B, as your wish. You can represent with any one of the value, no problem. Okay. Bulk modulus. So what is a bulk modulus? The bulk modulus is generally defined as K is equal to K. What is the K? K is equal to bulk stress by bulk strain. That is equal to F by A upon bulk stress. Bulk strain is a minus delta B upon B. This is what I am writing. F by A, force by area, that's what a pressure I am writing. Pressure upon minus delta B upon B. This is also what I am writing. K is equal to minus P into delta B upon B. Or magnitude of V P I am writing here. K is equal to, for small changes, this is also delta P into delta V upon V I am writing. Okay. Or this is also what I am writing. See here, delta V upon V is equal to delta V upon V is equal to the fractional change in volume of the object is given by, the fractional change in volume is given by delta V upon V is equal to, what is that? K upon delta V, or the percentage change in volume delta V upon V into 100 is equal to K upon delta P, K upon delta P into 100. This is what is that? Change in percentage change in volume of the bulk modulus. So already know we have discussed this previous concept. What is that? Bulk stress upon bulk strain. Bulk strain means suppose consider what is this is nothing but a sphere. When a force is applied, what happening is there is volume it changes. Therefore, bulk strain is equal to minus delta V upon V. इसमें bulk stress क्या हो जाता है? F upon A is called as a bulk stress. This is called as bulk strain. So the both of the ratios is called as, the ratios was given. What is this? The ratios was given. The both of the ratios is called as a bulk modulus. F is equal to F by A upon minus delta B upon V. That is the P upon minus delta B by B. Where F by A is called as a force by area is called as a pressure. That is P upon minus delta V by V. Therefore, K is equal to minus P. Here we have PV only, no? PV. Here see थोड़ा गलती हो गया, देखो इधर से देखो, इधर से देखो क्या मिल रहा है, थोड़ा गलती हो गई, इधर देखो k is equal to k is equal to what is the k is equal to minus pv upon delta v हो जाता है, ओके, pv upon delta v, pv upon delta v, pv minus pv upon delta v, और v is equal to क्या हो जाता है बोलो, minus delta v upon p into k. This is the initial volume in the form of minus delta p upon p into k. This is the initial volume, okay. This also what I'm writing, see here, k is equal to, so the p is in the form of a height and density. P is equal to h rho g into v upon what is that delta v हो जाता है. This is called as a bulk modulus. Next, compressibility. C is equal to 1 by k. The reciprocal of bulk modulus is called as compressibility. It is denoted by k. K is equal, it is denoted by c. C is equal to 1 by k. The reciprocal of what is that bulk modulus is called as a compressibility. Compressibility k. Okay, is it clear? So this is the concept of an bulk modulus. Okay, I hope you maybe understood the concept of the bulk modulus. So this is in the different forms is there, different forms. So इसमें क्या लिखना पड़ता है बोलो भाई, डेल्टा v इसको क्या लिखना पड़ता है इसमें, k is equal to k is equal to minus pv upon delta v. इसमें डेल्टा v क्या हो जाता है बोलो, डेल्टा v is equal to minus pv upon k हो जाता है, pv upon k. If v is in the form of क्यूब के लिए क्या हो जाता है, इसे क्यूब के लिए क्या हो जाता है, p v is equal to each of side of the लिए v is equal क्या हो जाता है, l क्यूब हो जाता है इसके लिए. Therefore delta v would be is equal to what is that, you can take this mod, that is p into l cube upon k, where k is called as a bulk modulus, or the change in volume of this object is given by delta v is equal to p to l cube upon k. So where p is, if p is in the form of a height and in the form of density g, then that value also you can put here. Then you will get the change in volume of the object. Okay. Next, see, based on this concept, one problem, see. From J का problem है बेटा, J ले, J problem देखो. Suppose consider a sample of water. एक sample है, इसमें water है. इसे sample, इसे sample, a sample of water. This is a sample of water which is placed at a pressure of P1 is equal to, initial pressure P1 is equal to 1 atmosphere. Okay. When the pressure on it is increases, same sample here beta. When the pressure on it is increases, when the pressure on it is increases, P2 is equal to 5 atmospheres. When the pressure has to be increased over the water sample, then what happening is that due to that, its volume has to be reduced. Its volume has to be reduced. Its volume has to be reduced. That is V is equal to or delta V is equal to what is that? Its volume has to be reduced 0.8 centimeter cubic, 0.8 centimeter cubic. इसका bulk modulus दिए, bulk modulus of the sample was given. Bulk modulus of the sample K is equal to 2 gigapascal. That is K is equal to 2 into 10 to the power of 9 Pascal है बेटा, 2 gigapascal दिए. Then find the initial volume of the sample. Initial volume कितना? Find the initial volume of the sample. This question was asked in 2025 J mains. J 2025. 2025. J mains 2025 में पूछा this question. Okay. Find the initial volume of the sample as shown in figure. Find the initial volume of the sample. Of the sample as shown in figure. As shown in this way. The sample initial placed under the pressure of 1 atmosphere. If the pressure is increased, what is that? 2 atmospheres. Due to that, its volume has to be reduced 0.8 centimeter cube. So iska bulk moles was given K is equal to gigapascal, that is 2 × 10 to the power of 9 pascal. Then find the initial volume of the sample. Iska initial volume कितने वो भी निकालना पड़ता है. Is it clear? Problem was clear or not? बहुत आसान problem है. Directly forward based में देखो. So the bulk moles was given K is equal to delta P upon minus delta V upon V है. Mod here because of negative sign is represented by decrease in volume. It could not be affected on the volume value. So this is what I am writing here. See, delta P into V upon delta V I am writing. Okay. What is the delta P? But 1 atmosphere is equal to how much you already know. Take here. Take 1 atmosphere is equal to 10 to the power of 5 pascal. Already knows 1 atmosphere is equal to 10 to the power of 5 pascal. That value substitute here. Delta P क्या हो जाता है बेटा? Delta P is equal to P2 minus P1. That is equal to 5 minus 1 is equal to 4 atmospheres. That is equal to delta P is equal to 4 into 10 to the power of 5 pascal. That is the value of delta P. Next to delta V. Decrease in volume was given. Delta V is equal to 0.8 into 10 to the power of 1 centimeter, 10 to the power of minus 2, 10 to the power of minus 2 whole cube, 10 to the power of minus 6 meter cube. 1 centimeter is equal to 10 to the power of minus 2 meters, 10 to the power of minus 2 of 4 cube means 10 to the power of minus 6. That is delta V is for simply what I am writing 8 into 10 to the power of minus 7 meter cube. So delta V, we have to calculate delta V also. And bulk moles also was given, but all values are put in that equation. Which equation? In this equation, we have to calculate the initial volume. No? Initial volume V is equal to K into delta V upon delta P हो जाते हैं. Okay, initial volume. इससे initial volume. K into delta V upon delta P है बेटा. Okay, V is equal to what is the value of K? K is 2 into 10 to the power of 9 into delta V was given 8 into 10 to the power of minus 8 meter cube by delta V. Delta V कितने में? Delta P. Delta P is equal to कितना बेटा? 4 into 10 to the power of 5 आ गया. 4 1 जा 4 2 जा 8 है बेटा. तो क्या आ गया बोलो? V is equal to 2 2 जा 4. 4 into 10 to the power of minus 8, 10 to the power of 9 gets cancelled, 10 to the power of 1 है. इधर 10 to the power of क्या हो गया बोलो? 10 to the power of minus 8, 10 to the power of 9 means 10 to the power of 1 है. 1 10 to the power of 1 into 10 to the power of minus 4 पर आ गया. Is it clear? पर आ गया. Is it clear or not? V is equal to K into delta V upon delta P है बेटा. 1 atmosphere is equal to 10 to the power of 5 pascal दिए. 1 centimeter 10 to the power of minus 2 better either. Okay, so this is a initial volume here better 10 to the power of initial volume 2 into 10 to the power of 10, right? Okay, this is the initial volume. Dekho, once I can see the problem. Find the initial volume of the sample as shown in the figure here better. इधर P1 दिया 1 atmosphere, P2 is equal to 5 atmosphere है. Due to that, ये decreased volume 0.8 centimeter, and its bulk mass was given 2 gigapascal. Then find the initial volume of the sample. Initial volume of the sample कितने हो जाता है बेटा? इतने हो जाता है मीटर क्यूब. Is it clear? Is it clear or not? Okay, note down. Next see. Next problem see, based on the concept on bulk mass only. Suppose find the fractional change in volume of a sea level. एक सी ऐसे है बेटा, दिस इज अ सी है, दिस अ सी है ऐसा, सी लेवल है, सी लेवल है, और इट हैज अ हाइट h इज इक्वल टू 2.5 किलोमीटर से इधर, 2.5 किलोमीटर से इधर इधर तक, इधर है पानी है पूरा, इसमें पूरा पानी है. ओके, the water the sea is consisting of water only, simply like this. Okay, right, this is a sea level only, sea would be like is there. At this point say due to atmospheric pressure over this like this, the atmospheric pressure is active over this like this. Okay, due to that, at a depth of h is for 2.5 kilometers, at this point to find the change in volume, fractional change in volume. And what was given here, see, the density of the water rho is equal to 10 to the power of 3 kilogram, and next g was given, acceleration due to the gravity is equal to 10 meter per second square, and इसका bulk mass k is equal to 2 into 10 to the power of 9 Pascal was given. So find the fractional change in volume there. Fractional change in volume at a depth of 2.5 kilometers of the sea water. Find the fractional change in volume of sea water at a depth of 2.5 kilometers. इसमें निकालना पड़ता है, तो फ्रैक्शनल चेंज इन वॉल्यूम at a depth of 2.5 kilometers. ठीक है, all values was given. This question was asked to JEE 2025 है बेटा, JEE 2025. Clear? How can we calculate the fractional change at that point? Already the bulk mass is equal to magnitude of minus PV upon delta V है बेटा. और K is equal to what I am writing? Delta P, or K value is what I am writing, see here. K is equal to P is equal to H rho G. I am writing in the form of H rho G into H rho G delta V upon V. V upon delta V. We have to calculate delta V upon V. Delta V upon V is equal to, what is the delta V upon V? H rho G upon K हो जाता है. That is delta V upon V is equal to, H value is a 2.5 into 10 to the power of 3 meters है, kilometers में दिए. That is 2.5 into 10 to the power of 3. The rho value is a 10 cube. Into G value is a 10 upon K value was given. K value is equal how much? 2 into 10 to the power of 9. 2 into 10 to the power of 9. Percentage निकालो into 100 से multiply करो. इधर से 100 से मल्टीप्लाई करो 100 हो जाता, ठीक है. Find the what is that fractional change in volume. Only this is a fractional change in volume. This is a percentage change in volume. देखो, find the percentage change in volume. First fractional निकालो. This is a fractional change है. Next percentage change हो जाता. Okay. What would be gets cancelled out here? See, 1, 2, 3, 6, 9, 9 gets cancelled out. Okay. That is delta V upon V into 100. Percentage change in volume is given by 25 by 2 into 10 to the power of -1. This is what I am writing. See here. So 10 to the power of -1 here, -1. That is 12.5 into 12.5 into 10 to the power of -1 here, beta. That is 1.25 हो जाए. This is a percentage change in volume. Delta V upon V into 100 would be is equal to 1.2 है. So this is a fractional change हो जाते हैं. This is a percentage change in volume of the sea level of water at a depth of 2.5 kilometers. Is it clear? Okay. Note. Next concept is the sharing modulus. Sharing modulus. It is generally denoted by neta. What is sharing modulus? Sharing stress upon sharing state is called as a sharing modulus here. Okay, take it. Suppose consider what is this cube here. Cube is a layer beta. This is a cube. Okay. This is a cube. I had applied some amount of force on it like this. How much amount of the force? Amount of the force has to be applied like this. What happening is there? What happening is there? Let's see here. It would be changes like this. Okay. It will be changes. That means the layers are displaced like this. The layers are displaced. The layers are displaced like this. The layers are displaced like this. Okay. This layer has to be displaced, making some angle theta like this. This length would be equal to L length. What would be L है? Oh, displacement क्या हो गया बेटा पे? What is this displacement? Delta x. Yeah. Theta is equal to what is the theta? Theta is equal to opposite by adjacent side. That is theta is equal to delta x upon L. Is called as a, what is this called? Strain. Sharing modulus can be defined as how much amount of the stress will be acting on this. Stress is equal to F upon, this much stress is acting over it. Therefore, sharing modulus theta is equal to F upon A is divided by theta. Or simply, this is what I am writing, F upon A into theta. So what is the value of theta? Theta value also already know, delta x upon L. Therefore, theta is equal to F upon A into delta x upon L. Delta x upon L. Delta x upon L is called as the theta. Or theta is equal to what is the theta? Theta is equal to F upon A into theta. Or what is that? Delta x upon L is equal to F upon A into theta. So what is the value of delta x? Lateral displacement delta x is given by delta x would be is equal to F into L upon A into theta is called as a lateral displacement, and this is called as a simply sharing modulus. The ratio of sharing stress to sharing strain is called as a sharing modulus. It is denoted by theta. That is theta is called F upon A upon theta. So these are the different forms of the sharing models. Okay, is it clear? Next, see, based on the concept C1 problem. So suppose consider a rod here, beta a rod of length 1 meter है बेटा इसका L is equal to 1 meter and has a radius 4 centimeters. It has a radius 4 centimeters. The rod has a radius how much? 4 centimeters. R is equal to 4 centimeters. And one end is fixed like this at the bottom. On the surface of the rod, a force of F is equal to 10 to the power of 5 newtons. A force of F is equal to 10 to the power of 5 newtons is applied. 10 to the power of 5 newtons is applied on the surface. When that much force has to be applied on this, what happening is there? The rod has to be displaced through a small angle theta like this. From original direction to the rod has to be displaced like this, making some angle theta. Small angle theta ऐसा डिस्प्लेस हो गया. So इसका rod का sharing modulus is equal to 10 to the power of 10 Pascal was given. Then calculate the what is the value of theta. Value of theta निकालना पड़ता है इसमें. Theta value कितने? What is the value of theta? Theta would be equal to how much? That means stress is equal to how much? Sorry, strain is equal to how much? We have to calculate the strain. Okay, how can we calculate the strain? See here. The sharing modulus was already known. So theta is equal to F upon A theta, where theta is equal to F upon A into theta is already. The rod of area of the cross section is in the form of a circle. So that's what in the area I'm writing pi r square. A is equal to pi r square. Therefore, theta would be is equal to F upon pi r square into theta I am writing. Okay. What is the theta? Theta is nothing but a strain. The strain produced in the rod. Therefore, what is the value of strain produced in the rod? Theta is equal to F, that is 10 to the power of 5 newtons upon pi. R value is 4 centimeters. That is 4, what I am writing here, 4 into 10 to the power of minus 2 meters I am writing. R square means 16 into 10 to the power of minus 4 meters square. Okay. R square into theta. What is the value of theta? 10 to the power of 10 was given. This is 10 to the power of 10 is theta was given. Okay. 10 to the power of 5, 10 to the power of 10, 10 to the power of 4 is there. Sorry, 10 to the power of 5 is there. 10 to the power of 5, 10 to the power of minus 4, 110 is there. Therefore, theta is equal to what is the value of theta? See here. What is the value of theta? Theta is equal to 1 by 165. This much strain has to be produced in that rod. Is it clear? This is also a JE question only. This question was asked in 2025. JE. This one is JE question. This question was asked in 2020. A rod of length was given where L is equal to 1 meter. Its length 1 meter was given. On this, how much amount of the force is applied? 10 to the power of 5 newtons force will be applied. Due to that, it has to be bent like this. Due to this force, that means the strain has to be produced. Then calculate the or find the strain in the rod. Find the strain in the rod. Find the strain in the rod. I showed in figure. I shown in figure. I showed in the figure. Okay. Strain कितने हो जाते बेटा? कितने हो जाते? Is it clear? Okay. नोट लो, बहुत आसान प्रॉब्लम है। नेक्स्ट सी रिलेशन बिटवीन y k neta and sigma. Relation between y comma k neta and sigma. Okay, how we can remember the relation between y k and sigma and neta? See what I'm writing. See here, first I'm writing here y I am writing here, neta writing here, k I am writing. Okay, and I am multiplying with 1 minus sigma for this. This also I am multiplying with 1 plus sigma. This also I am multiplying with 1 minus sigma. Okay, is it clear? इसको क्या कर रहा हूं, तो सिग्मा को 0 से मल्टीप्लाई करो इंटू 0, तो सिग्मा को क्या से कितने मल्टीप्लाई करो 1, तो सिग्मा को कितने से मल्टीप्लाई करो इंटू 2. This is the total value multiplied with 1, this total value multiplying with 2, this total value multiplying with 3, and all of them equal करो इसमें. Y is equal to what I am writing, see here, y is equal to 2 neta into 1 plus sigma. Okay, this is 0 हो गया पूरा, और 0 that is equal to 3k into 1 minus 2 sigma. This is a relation between yk and neta. Sometimes this question also asking, will be asking on JEE main से बेटा, तो दोनों का रिलेशन निकालो, तो दोनों का रिलेशन मिल जाता है y is equal to 2 neta into 1 plus sigma. इसमें neta is equal क्या हो जाता है बोलो, neta is equal to y upon 2 into 1 plus sigma हो जाता है. ओके, वो दोनों के लिए क्या मिल जाता है बोलो, 2 neta is equal to 2 neta into 1 plus sigma is equal to बोलो 3k into 1 minus 2 sigma. इसमें k वैल्यू निकालो, k इज इक्वल क्या मिल जाता है बोलो, k इज इक्वल टू 2 neta into 1 plus sigma upon 3 into 1 minus 2 sigma. This is a relation between k and neta. This is a relation between y and neta, and y and k क्या मिल जाता है बेटा बोलो, तो दोनों भी इक्वेट करो y and k में. y and k में क्या मिल जाता है बोलो, y into 1 minus sigma is equal to 3k into 1 minus 2 sigma है. ठीक है, इसमें y is equal क्या मिल जाता है, y is equal to और k is equal as your wish, where y is equal to 3k into 1 minus 2 sigma upon 1 minus sigma है बेटा. This is a value of relation between y and k. Is it clear? बहुत आसान है. So how we should have to remember this value? See here, Young's modulus and sharing modulus. This is a bulk modulus. But first you should write individually like this. And first is multiplying with 1 minus sigma. Second one is 1 plus sigma. Third one is also 1 minus sigma. So sigma को 0 से multiply करो, 1 को and 2 को. इसको 1, 2, 3 and all of them equate करो. All of them you should have to equate, and you will get the one of the Brahmastra equation है बेटा. This is Brahmastra, the relation between y, neta and k. इसमें कोई भी चीज मिल जाता है. So from this term we will have calculate the relation between y and neta में 100 मिल जाते हैं, k and neta को वो मिल जाता है, and y and k को वो मिल जाता है. Okay, is it clear? Is it clear or not? No doubt. Okay. Do you have any question on the today concept? Please ask me. on the scrolling number.
స్టూడెంట్స్ కి ఎటువంటి డౌట్స్ ఉన్నా మీరు ఇప్పుడు రాసి పెట్టుకున్న డౌట్స్ ని అన్మ్యూట్ చేసి సార్ ని డౌట్స్ అడిగితే సార్ మీ డౌట్స్ క్లారిఫై చేస్తారు. స్టూడెంట్స్ కి ఏం డౌట్స్ లేవా? ఇప్పటి వరకు విన్న టాపిక్ లో డౌట్స్ ఏమైనా ఉన్నాయా? డౌట్స్ ఉంటే దయచేసి అన్మ్యూట్ చేయండి. భద్రాచలం అన్మ్యూట్ చేసి అడగండి. అడగండి. ఎవరికి ఏమైనా డౌట్స్ ఉన్నాయా ఇంకా?
Okay.